Hi everyone, and welcome back to educator.com. Today's mini lesson is going to be on projectile motion as we work through page 1 of the A+ Physics worksheet on projectile motion, and you'll find the link to that worksheet down below. Let's dive in with number 1. A volleyball hit into the air has an initial speed of 10 meters per second. Which vector best represents the angle above the horizontal that the ball should be hit to remain in the air for the greatest amount of time? Well, obviously, if you want it to remain in the air for the longest amount of time, you want it to have as much vertical velocity so it goes as high as possible. So the answer there must be 1. You want it being sent completely vertically. All of the energy being sent into its vertical motion so it's in the air for the longest amount of time. Now, following on from here, on the diagram, use a protractor and a ruler to draw a vector to represent the initial velocity of the projectile, given that it's launched at 250 meters per second at an angle of 60 degrees. Begin the vector at P and use a scale of 1 centimeter equals 50 meters per second. If 1 centimeter is 50 meters per second, our vector is 250 meters per second long, our vector should be 5 centimeters long. So that should look something like this, where our velocity here is 250 meters per second, and our angle there, check with the protractor, should be 60 degrees. All right. We've got a projectile fired from the ground again. Same projectile, same velocity, same angle. Determine the horizontal component of the initial velocity. Well, the horizontal component is going to be the x component, which will be v times the cosine of our angle, 60 degrees, or 250 meters per second, times the cosine of 60 degrees. And cosine 60 degrees is 1/2, so that's going to be 125 meters per second. And number 4, explain why the projectile has no acceleration in the horizontal direction. Well, there's nothing to cause a force in the horizontal direction. If we're neglecting air resistance, there's nothing to change its velocity. Once it's going horizontally, gravity is only pulling down, doesn't affect the horizontal velocity. So why is there no acceleration? I would write something like gravity only pulls down. All right. Number 5, we have 2 stones, A and B. Those are kind of goofy names for stones. They're thrown horizontally from the top of a cliff. Stone A has an initial speed of 15 meters per second, and B has an initial speed of 30 meters per second. Compared to the time it takes A to reach the ground, the time it takes B to reach the ground is, well, if we're launching these from a cliff, there goes A. B has a greater initial velocity, but that has nothing to do with their vertical motion. Regardless of whether you drop an object, throw an object, shoot an object, as long as you have no initial vertical velocity and you have flat ground for them to land on, they'll hit the ground at the same time. That's similar to the famous thought experiment where you drop a bullet from a gun and fire the gun horizontally at the same time. Assuming that the ground is completely flat, the bullets hit the ground at the same time. So, comparing the amount of time it takes, the same. One more. This diagram represents the path of a stunt car driven off a cliff, neglecting friction. Compared to the horizontal component of the car's velocity at A, has some velocity at A horizontally. The horizontal component of the car's velocity at B is, well, we've hit that a couple times already just on this page of the worksheet. The horizontal velocity isn't going to change. Gravity only pulls down. So in this case, the horizontal components of its velocity still going to be the same. All right, that completes page 1 of the worksheet on projectile motion. Thanks so much for your time. Make it a great day.